Hello, today we're talking rotations. To rotate something means to turn a figure about a fixed point called the center of rotation. So if we're looking at this little pinwheel off to the side here, right here would be the center of rotation, and they're pointing out the angle of rotation. We have to be careful to talk about which direction we are rotating in for that angle of rotation. So just as a reminder, when we say clockwise, we are going with the clock to the right, and if we are counterclockwise, we are the opposite way to the left. So if we start in the middle of the page here with this pre-image in the first quadrant, and if we take it and rotate, all of these rotations will be done around the origin. If we rotate counterclockwise 90 degrees, that's going to take us into the next quadrant to the left. And if you look at what's happening with the coordinates there, let's say I look at the point, the original pre-image point 4, 3. You can see that that would now correspond with this point, -3, 4. Or if you take a look at the original point 5, 1, it would now correspond with -1, 5. So what we're doing there when we perform a 90-degree counterclockwise rotation is we are swapping the position of the coordinates. So the 3 goes first, the 4 goes second, and then we're negating or taking the opposite of that number that's now in the front. So if we look to the box down here, when a point AB is rotated counterclockwise about the origin, the following is true. For a rotation of 90 degrees counterclockwise, the original point AB becomes -BA. And anytime we say -B, we mean the opposite. So if it already started negative, it would actually become positive. Okay, then if we go back to the pre-image, let's say that we rotate 180 degrees, as you're seeing upside down here, halfway around the circle, so 2 quadrants away. If we look at the same original points, 4, 3 would correspond with this point at -4, -3. 5, 1 would correspond with this point, -5, -1. So what we're doing there when we do a 180-degree rotation is we're just taking the opposite of both coordinates, but we're not changing their position. So for a rotation of 180 degrees, AB becomes -A, -B. And then for the last one, if we start in the pre-image and we rotate 270 degrees, 3 quadrants away, this point 4, 3 now corresponds with 3, -4. This point 5, 1 now corresponds with 1, -5. So again, we are swapping the position of the numbers. So the 3 and the 4 swapped positions, and then the second number is now being negated. Same thing here. The 1 and the 5 switch places, and the second number, the 5, is negated. So generically down here, for a rotation of 270 counterclockwise, all of these are counterclockwise, AB becomes B, -A. Now, if we talk about direction for a second, well, first of all, if we were to make it 360 degrees all the way around, 360 is the full circle and would just get us right back to where we started. When we talk about 180-degree rotation, it doesn't matter whether we say it's counterclockwise or clockwise, because we're going to end up in the same position no matter the direction. But with 90 and 270, it is important to talk about the direction of the rotation, being clockwise or counterclockwise. And then one other thing I wanted to point out, since our rules down here are only written specifically in terms of being counterclockwise, if I rotate, let's say, take my pre-image and go counterclockwise 90 degrees, that's actually the same result as if I went clockwise 3 quadrants away 270. So I just want to point out that a rotation of 90 degrees counterclockwise is equal to a rotation of 270 clockwise. And in a similar way, if I took my pre-image and went counterclockwise 270, that would be the same result as if I simply went clockwise 90. So a rotation of 270 counterclockwise is the same result as 90 degrees clockwise. So if it ever talks about clockwise, you can always relate it back to this rule that's counterclockwise because the movement is equivalent. Okay, if we finish up, we'll go off to the side here. Just making sure I'm not forgetting to say anything that I wanted to say. We'll finish up here. It says graph triangle ABC with vertices A is at 3, 1, B is at 3, 4, and C is at 1, 1. And we want 180-degree rotation about the origin. So since it's 180, it's not important to say clockwise or counterclockwise. If I use my rule, all I need to do is take my original coordinates and negate them all. So A prime, if A is at 3, 1, A prime would be at -3, -1. If B is at 3, 4, B prime would be at -3, -4. And if C is at 1, 1, C prime would be at -1, -1. And so you can see that this indeed would look correct if we were to rotate this 180 degrees. At the bottom, this box is just giving you some examples of figures that have rotational symmetry, which means the figure can be mapped onto itself by a rotation of 180 degrees or less about the center of the figure. So if you drew in a center point for each of these, and you think about turning it or rotating it less than halfway around, it should eventually at some angle map onto itself or be exactly the same and match. And the last example over here says graph segment RS with endpoints 1, -3 and 2, -5. So there's the original. The first transformation, we're supposed to rotate 180 degrees about the origin. So again, I'm just negating the coordinates. So +1, -3 would go to -1, +3. And the new S prime, if S was at 2, -5, this will go to -2, +5. Okay, so there's the rotation halfway around the circle, either direction. And then the last one, we want a reflection of that in the y-axis. Remember, here's our vertical y-axis. Point S is 2 units away. So here would be S double prime. Point R is 1 unit away. So our double prime would be there. Again, I do want to point out with rotations, translations, and reflections, the original pre-image and the image we end up with after whatever we've done to it, they are still congruent, still same size and shape.